It's April 27th and came outside again today to this time try to illustrate the way in which weather behaves along the fronts. So we're going to look at these fronts from the side. I'll draw a few diagrams and try to explain again the way weather behaves, air behaves, water vapor behaves along the different types of fronts. We're going to try to do a cold front for you. So I'll make a little box. And so here's a little frame in which we might then put a cold front. And cold fronts are depicted, if you're looking at it from the side, so this would be the ground here. The cold front would be coming down or coming across the frame from left to right, and it has this strong arcing shape, and that arcing shape, and again moving in this direction, typically continental polar air behind the front. This would be the front triangles heading in this direction. This is the ground, and what happens is it catches up with some maritime tropical air, which, because that maritime tropical air has so much water vapor in it, is less dense. It's a zone of lower pressure, less dense than the colder air, and the air is swept up the front. And that sweeping up of the air creates clouds of vertical development. And those clouds of vertical development then create strong zones of precipitation. So along this front, we can expect clouds of vertical development, lots of rain, wind, and thunder and lightning storms. A cold front moving through a region, driving warmer, moisture air in front of it up along the front to, and remember, this could be anywhere from 0 to 5K, 5 kilometers above the earth. So air is being swept up, causing very unsettled weather. That's your cold front. Hello everyone. A warm front. So a warm front, again, making a simple frame. With, again, the ground here, so we're looking from the side. A warm front, typically with some maritime tropical air, will encounter continental polar or cooler air in front of it, and again the maritime tropical air moving in this direction. And what happens is, rather than that steep slope, you get a more gradual slope up, where warm moist air is lifted over the denser cooler air. So, as we already have learned, this maritime tropical air will be less dense, warmer, filled with water vapor, and it will rise over this shallow slope, or rise up this shallow slope over the denser continental polar air. And then along that front, you have drizzly, rainy stratus clouds. So we have stratus as opposed to clouds of vertical development. And it's a gray, seasonally cold, warm, hot, depending on the time of year. All right, so that's your warm front. Again, the key with a warm front is this shallow slope up which moisture-laden air flows over the denser, colder. And then again, this front is not moving as quickly as our cold front was. All right, everybody, now we want to try an occluded front. What's the weather look like along an occluded front? So, again, make a frame. With the ground. This time, as we may have already understood, the occluded front includes a warm front and a cold front meeting. The cold front, with that arcing shape heading in this direction, continental polar air, meeting a warm front with a much shallower slope, up which warm moist air travels, up which along the cold front warm moist air travels. And so of course we then have precipitation along this front and stormy weather along this front. Again, this front will have its clouds of vertical development with potential thunder and lightning storms, and on this front, stratus clouds, perhaps nimbostratus, and the like. And this whole zone then, where these two fronts are meeting, becomes tremendously unsettled weather. I would add one last thing here. We have to remember that what is being collided into by the cold front is, of course, maritime tropical air. So this would be maritime tropical in here. And again, this is cooler air, right, at the warm front, that the warm front is rising, that the warm air is rising at the shallower slope over. So you have these two fronts with their characteristic weather now meeting. This is your occluded front. Stationary. Again, a frame. And a little bit of the ground. And what we have here is a cold air mass and a warm air mass. And I really shouldn't have done this so close. A little bit of space in between, but not so much. That's okay. And neither air mass capable of really moving past the other. And again, in this case, your warm air mass would have been flowing in this direction, and your cold air mass would be flowing in this direction. And you could still have your continental polar air and your maritime tropical with a little bit of cooler air here. And again, this will be a situation where there is unsettled weather with air rising along here and air rising along here, but nowhere near as dramatic as your occluded front. And the reason for that is that neither one of these fronts can overtake the other, can move past the other. And so you just get several days of unsettled, rainy weather. Probably a little bit more rain, in fact, than your warm front. Not as much as your cold front, and certainly not as much as your occluded front. So this is your last one, your stationary front, where the two fronts just essentially bang into each other, heading again in opposite directions, neither one of them able to push, as it were, the other out of the way. And a final review again, our warm front always depicted with the half circles, and our cold front always depicted with the beautiful blue triangles. Your warm front, your cold front. On a diagram of a stationary front.
Well, a cold front has come through, and it is chilly. And to review, the cold front moving quickly with a steep front runs into warmer air and drives that maritime tropical moisture-laden rich air up the front, developing clouds of vertical development, potential thunderstorms, winds, can have in the winter blizzardy conditions, and often the front passing through fairly rapidly, followed by a warm front. That was our second discussion. Here, a slower moving front of warm air runs into cooler air, and a shallow slope develops up which maritime tropical or moisture-laden rich air can move, rising, cooling, condensing, and dropping light rain, drizzly, gray, not particularly windy or stormy weather along a warm front. Then the two fronts meet. An occluded front, that continental polar air crashing into, catching up, moving quickly, and crashing into the warm front, and air rises moisture rich, moisture laden along both fronts, along the steep cold front, clouds of vertical development along the warm front, nimbostratus horizontal, low air energy clouds, bad weather where the occlusion takes place. The occlusion often ascent near the center of a low pressure system, drawing air in from all directions. And finally, our stationary front, where a cold front meets a warm front, and neither can move, and over an area for several days, unsettled but not tremendously stormy weather. Rain along the entire front with cold air pressing in one direction, warm air in the other. Often in the middle of our nation, where continental polar and maritime tropical would meet, but often where there's not a great difference in, say, pressure conditions on either side of the front. And that's our story today of fronts.